Hello everyone, this is Priyanka Sutar, Assistant Professor of Galot Institute of Pharmacy, and today I am going to discuss systematic nomenclature system of heterocyclic compound, that is a Hantzsch-Widman system. Now Hantzsch-Widman system is a systematic method which is used to write name of 3 to 10 membered monocyclic heterocycle. Basically it is for a heterocycle which is a monocyclic, that is a single cycle of various degree of unsaturation. There may be double bonds which are present, and 2-3 double bonds or one double bond, plus which contains one or more heteroatom, various double bond and heteroatom system. Okay, so in short, this system of the nomenclature is used for heterocycle which are unsaturated and contains one or more than one heteroatoms. Particularly this system which is there, it specifies a ring size. The name of the compound given by this system gives you idea about the ring size, what is nature, type and position of heteroatom which is present in the heterocycle. So ring size, and so it gives idea about a ring size and heteroatoms. For example, this particularly this heterocycle is named as a 1,3-thiazole. As per Hantzsch-Widman system, it is named as a 1,3-thiazole, whereas particularly this compound is named as a 4H14-thiazine. So these are the basic 5 rules of Hantzsch-Widman system. We are going to learn all these rules one by one, starting with the first rule, combination of prefixes with stem. So nomenclature of particularly this system which we are learning, it is applicable to monocyclic system, and the name consists of 2 parts. First part is a prefix and second part is a stem. And prefix which is there, it indicates heteroatom, whereas stem part indicates the size of the ring. And there is a very important rule. This is a very important rule of Hantzsch-Widman system, that if the stem begins with a vowel, the terminal letter A of prefix is dropped. Now how to apply this rule we will see when the rule comes. When we are practicing the solution problems, we will see how you can apply this rule. For now, just remember, if the stem begins with the vowel, you will drop A of a terminal A of prefix. So as I said, prefix is what? Prefix indicates heteroatom which is present in the heterocycle, where and this prefix, what are the prefix? Like for different heteroatoms, what are the prefix which are used, that are mentioned in table number 1 in a preferential order. Now there is a order of that heteroatom also, that we will see in a table number 1 in a while. And stems indicates size of the ring. Along with the size of the ring, it gives idea whether the ring is saturated or unsaturated, specifically for heteromonocyclic ring. So if means what, it is applicable to the single ring. If there are 2 rings, there are different rules for the fuse system, which we will see in the another session. And for this particular stem, there is a table number 2. We will see table number 2 in a while. Now this is a table number 1 of prefixes. Here you will see heteroatom symbol and prefix. Oxygen is a heteroatom, okay, and its symbol is O, capital O, and its valency is 2. and its prefix is oxa. Okay, remember the terminal letter A. The prefix has a terminal letter A. Second heteroatom is sulfur. Its symbol is S and its valence is 2. And its prefix is thia. Again note that the prefix is ending with the vowel, ending with the A. Selenium symbol is Se, valence is 2, prefix is selena. Tellurium, Te is a symbol, valence is 2, tellura is the prefix. And nitrogen, if heteroatom is a nitrogen, then its symbol is 2, valence is 3, and it is aza. Now, as far as pharmaceutical organic chemistry 3 is concerned, we will only deal with 3 heteroatom, that is oxygen, sulfur and nitrogen. So, from table 1, I suggest you for now, for semester 4, you just refer these 3 heteroatom, the prefixes of 3 heteroatom, that is oxygen means oxa, for sulfur it is thia, and for nitrogen it is aza. Now note that terminal letter of this heteroatom ends with the A, that is the terminal letter is A. So these are the remaining heteroatom, but I said that we will deal with the 3. So remember the prefixes of these 3 heteroatom, and I suggest you to take a pen and paper and note it down, because it will be useful for you in the upcoming slides. Okay, so take a pen and pause the video, take a pen and paper and note down the prefixes for the heteroatom and name it as a table number 1. Now we will see table number 2, which is for stem. Table number 1 indicates what? Table number 1 indicates heteroatom, right, which is a prefix. And second part of the name Hantzsch-Widman system is stem, which indicates ring size and presence of unsaturation. It also indicates unsaturation and saturation. Now, if the ring size is 3 member, if the ring size ring consists of 3 members, then if the ring is unsaturated, then you can write IRENE, and if the ring is saturated, 3-member ring is saturated, then you can use stem IRANE. Then 4-member ring, if 4-member ring and a ring is unsaturated, then you can use stem ETE, and if 4-member ring is saturated, then you can use ETANE, etane. If 5-member ring, if the compound, heterocyclic compound is 5-member ring and it is unsaturated, then you can use stem OLE. And if a heterocyclic compound is 5-member ring and the ring is saturated, means there is no double bond in the heterocycle, then you can use stem OLANE, olane. Then if the compound is 6-membered ring and unsaturated, then you can use ione as a stem, and if the compound is saturated, then you can use ANE. Then if the compound is 6-membered and it contains heteroatom as a nitrogen and the heterocycle is unsaturated, then you can use ione. Okay, and if the compound is 6-membered and it is saturated and it contains heteroatom nitrogen, then for saturated compound you will use stem enane, INANE. And see, and you can see for A type of 6-membered ring, if A type of 6-membered ring that contains oxygen and sulfur, if it is saturated, you can use stem ANE. And there is an exception. If 4-member ring contains nitrogen Okay, if 4-member ring contains nitrogen, then saturated ring saturated ring will be named as a iridine, means the stem of that saturated ring will be iridine. 5-membered ring saturated and contains nitrogen, then you can write it. Saturated 6-membered ring, saturated 6-membered ring contains nitrogen, you can write olidine. Okay, you can use stem olidine. C, no need to use the C, because as I said, we will be dealing with the 3 heteroatom, so you remember for only these two. Okay, 6-membered A type, B type. A type means what? The heteroatoms which contains oxygen, sulfur. B type 6-membered which contains nitrogen. The only difference is in the saturated system. Then 7-member ring epine, 7-member unsaturated ring stem you will use is epine, and 7-member saturated then you can use epane. Like this, the list of stems are given here in a table number 2. So you pause the video and write the stems of the ring. Now we have learned basic rule that according to Hantzsch-Widman system, the name of the heterocycle is made up of 2 parts. First part is prefix, second part is stem. Okay, and prefix, for prefix you have table number 1. Okay, prefix for you have table number 1. Out of that table you have to remember only 3 heteroatoms, and for stem you have a table number 2. So very important, you need to learn this table number 1 and table number 2. Okay, so make sure you know table number 1 and table number 2 in order to understand the Hantzsch-Widman system. Now moving on to second rule, presence of identical heteroatom, that is a multiplicity of heteroatom. Now first rule you have understood that it tells you about the ring size and the prefix, and that specifically is applicable to one heteroatom. What if there are multiple heteroatom, like 2 heteroatom, 3 heteroatom present in the same ring? So how you can write? Rule number 1 does not specify how you can write the name of a heterocycle if there are 2 or 3 heteroatoms. So rule number 2 is for the multiple heterocycle which contains multiple heteroatom, that 2 heteroatom should be identical. Okay, heteroatom will be there. Multiple heteroatoms may be present in a heterocycle, but that multiple heteroatom should be identical. In that system, how you will write the name? When 2 or more heteroatoms of the same type are present in the ring, the prefix di, tri, tetra are used and placed before the prefix. So what will be the sequence? If identical heteroatoms are present, if 2 heteroatoms are present, then you will write di followed by prefix followed by stem. This way you will go. Okay. So here is an example. Here are the examples of such a system. Now we will see all these examples one by one. Now when I am explaining this structure, I will be giving some questionnaire. Okay, I will be giving some questionnaire and there will be some answer to that questions. So you take a pen and paper, write those questions, write the answers to that questions and get the name of the compound. So this way you understand better. So in between you can pause the video, or side by side as a running notes you can write the only name. Okay, starting with the first compound. So first question, whenever you see a structure, first thing you have to do is to identify the heteroatom and write the name of the prefix. As you know, as per Hantzsch-Widman system, there are 2 parts. First part is prefix, second part is stem. So we'll start with the prefix. So prefix indicates what? Heteroatom. So you have to identify what is the heteroatom. So you can write the answer. What is the name of the heteroatom? For that you need to refer table number 1. So if you have written a table number 1, refer the table number 1. So the heteroatom present in this heterocyclic structure is oxygen, and as per table number 1, name of the prefix is oxa, right? Second question, number of heteroatom. How many heteroatoms are present? 2, right? 1 and 2. So as per rule number 2, multiplicity rule, what will be the name? You will attach di. For 2, you will attach di to the prefix. So name will be dioxa, and you name it, right? Now name it and number it. So you also have to number it. So 1, 2, 3. So you number it as a 1, 3 dioxa. Di also you have to mention where is the place of that heteroatom. Now next, now you are done with the prefix. Now you will go for stem. Identify number of atoms which are present in the ring, and name the stem. Now see how many heteroatoms are present. How many atoms total? How many atoms are present in the ring? 1, 2, 3, 4, 5. So 5 atoms are present in the ring. So for this, now you will refer table number 2. Now this ring is 5-membered ring and it is saturated. So what is the stem for 5-membered ring which is saturated? Refer table number 2. So the stem is olane. Okay. Now that rule we have learned. What is that? Drop A if stem starts with vowel. You can see the stem is starting with the vowel. A, E, I, O, U are the vowels and it is starting with the O. So what you will do? You will drop A of the prefix. Terminal A of the prefix is dropped and the name will be 1,3-dioxolane. So this is the name of this structure, 1,3-dioxolane. Now we will see second compound. Now you have understood how you will go. So take a pen and paper and just write the answer. I will ask you question. You write the answer in your notebook. Now you see the heterocycle on the screen. Identify the heteroatom and name the prefix. Refer table number 1 for the prefix. What is the heteroatom? Heteroatom is nitrogen. So according to table number 1, what is the prefix? It is aza. Okay, it is aza. Second question. How many numbers of heteroatoms? How many numbers of heteroatoms? There are 3 heteroatoms. So as per rule number 2, how you will write prefix? You will write it as a triaza. Now next question. Now you have to number it and then name it. So numbering 1, 2, 3, 4, 1, 2, 4. 1 to 4 triaza. Now see, this number and this name is separated using this hyphen dash. Next question. Identify number of atoms which are present in the ring and name the stem. Now here, till here you are done with the prefix part. Now you are moving on to the stem part. Now you need table number 2. So how many atoms are there? 1, 2, 3, 4, 5. 5 atoms in the ring, that is 5-membered ring, and this ring contains double bond, right? So this ring contains double bond, so it is unsaturated. So you look for the 5-membered ring which is unsaturated. What is the stem? Refer table number 2. It is OLE. Now you are done with the stem, you are done with the prefix. Now there is one rule remaining. Drop A if stem starts with vowel. Stem starts with the vowel O, then you will drop A, terminal A. So what will be the name? Now write down the name. What will be the name? Write complete name. It will be 1, 2, 4 triazole. So complete name will be 1, 2, 4 triazole. Okay. Moving on to next example. First question. Now you see the structure on the screen. Identify the heteroatom and name the prefix. What is the heteroatom? It is nitrogen. Refer table number 1. What is the prefix for nitrogen? It is aza. Right? Now identify number of heteroatom. How many nitrogens are there? 2. So name will be as per rule number 2. What will be the name? Diaza. Next, number the heterocycle and name it. So it is what? 1, 2, 3, 1, 3 diaza. Now here you are done with the prefix. Now moving on to the stem part. Now identify number of atoms which are present in the ring and name the stem. For this you need a table number 2. So this is a 6-membered ring which contains double bonds, means it is unsaturated. So what is the stem of 6-membered ring which is unsaturated? Refer table number 2. So the stem is INE. Now the rule, drop A if stem starts with vowel. So terminal A you have to drop, right? So write the name of the structure. Now write name of the structure. It will be 1,3-diazine. So it will be 1,3-diazine. Moving on to the next structure. Now you are getting at it, right? We'll go fast. Identify the heteroatom and the name. Heteroatom is nitrogen. As per table number 1, prefix is aza. As per rule number 2, multiplicity rule, you will look for the number of heteroatom. So there are 3 heteroatoms, identical. All heteroatoms are identical, and 3 heteroatom. So it is triaza. You number it and name it. 1, 2, 3, 1, 2, 3, 4, 5. So 135 triaza. Now here you are done with the prefix part. Now moving on to stem part. Identify number of heteroatoms. 6-membered ring which is unsaturated. What is the stem? You can refer table number 2. It is INE. And one more rule, drop A if stem starts with vowel. Drop A if stem starts with vowel. Stem starts with vowel I. So you will drop this terminal A of prefix. So name will be 135-triazine. It will be 135-triazine. Now you have learned rule number 1 and rule number 2. That is combination of prefix. What is Hantzsch-Widman? As per Hantzsch-Widman system, the name of heterocycle is of 2 part, prefix and stem. Prefix indicates heterocycle, stem indicates cycle, ring. Okay, and rule number 1 is applicable if there is only one heteroatom. But what if there are two heteroatoms which are identical? Then you can use di, tri, tetra prefix before prefix. Now what if there are multiple heteroatoms but the heteroatoms are different? In case of rule number 2, the heteroatoms were identical. If nitrogen is there, there were two nitrogen. If oxygen is there, there were two oxygen. So what if there are 2 or 3 heteroatoms which are different? So here order of preference combination rule is used. So if 2 or more different heteroatoms are present in the same ring, okay, same ring, not different ring, same ring, the prefix of heteroatoms are combined. So you will use table number 1 for the prefix, but those prefixes will be combined in order of their appearance in table number 1. But order, you will choose. So which one you will place at first and second, that table number will decide. So here are the examples of that same. So you see table number 1. What is the order of preference? First preference is for oxygen. Second preference is for sulfur. Third preference is for nitrogen. Right? That's why I wrote over here OSN. First preference for oxygen. Second preference for sulfur. Third preference for nitrogen. So I call it as a OSN rule. Second rule is for different heteroatom, OSN rule. Now we will see examples. So write down this example, and again I will be giving some questions, and you have to write the answers to the question, and eventually you will get the name of the compound as per Hantzsch-Widman system. So first question is identify heteroatom and name the prefix. For this you will refer table number 1. Okay, table number 1. So what are the heteroatoms? Nitrogen and sulfur. Prefix for the same are the aza and thia respectively. Now you refer table number 1 again for order of heteroatoms. So what is the order? OSN. I have also written over here. What is the order? OSN. So you have to arrange these two prefixes in such a way that it will be in preferential order. So first oxygen. Oxygen is not there. Sulfur, yes, sulfur is there. Nitrogen is there. So first you place prefix of sulfur, and then you place prefix of nitrogen. So name will be, so the prefix will be, not name, sorry. So the prefix will be thia, aza. So this will be the order. Okay. Now you number it. Now my 1, 2, 3. So heteroatoms are present at first and third position. So what will be the name of the prefix? It will be 1, 3 dash thiaza. Okay. Now we are done with the prefix. Moving on to the stem. You identify number of atoms which are present in the ring and name the stem. How many atoms are present? Total 5 atoms are present, and there are 2 double bonds, means the system is unsaturated. System is unsaturated means what? Now you will refer table number 2 for 5 membered ring which is unsaturated. What is the stem? It is OLE. Now the final rule, you will drop A if the stem starts with the vowel. You will drop A, terminal A of prefix if the stem starts with a vowel. It starts with the O, so you will drop this A and you will write the name. Now write the name of this structure. What will it be? It is 1,3 thiazole. 1,3 thiazole. 1,3 thiazole. Moving on to the next example. Again, same questionnaire. Identify the heteroatom and name the prefix for this. You refer table number 1. What are the heteroatoms? Nitrogen and sulfur. So prefixes for the same are the aza and thia. Again, refer table number 1 for the preferential order OSN. Sulfur and nitrogen are there, so your preference order will be thia, aza, thia and aza. You have to number it 1, 2, 3, 4. Previously it was 5-membered ring, right? And it was the position was 1, 3. So here it is 1, 4, right? 1, 4. So name will be, name of the prefix will be 1, 4 thiaza. Now we are done with the prefix. We will go for the stem. Identify number of heteroatoms. Sorry, identify number of atoms in the ring and name the stem. It is a 6-membered ring which is unsaturated. So name of the stem is INE. 6-membered ring and unsaturated. You refer table number 2. It is INE. Now the rule, drop A if the stem starts with the vowel. I, if the stem starts with the I, which is a vowel. So you will drop this terminal A of the prefix. So name will be, write down the name of this structure. It will be 1, 4 thiazine. That is a 1, 4 thiazine. Moving on to the next example. Identify the heteroatom, name the prefix. Heteroatoms are oxygen and nitrogen. Prefix is aza and oxa. As per rule number 2, you have to see the table number 1 for the preferential order. As per table number order is OSN. So oxygen comes first, followed by nitrogen. So order is oxygen, nitrogen, oxaza. Now you number it 1, 2, 3, 4. So name of the prefix will be 1, 4 oxaza, because A, double A is there, so 1 A is dropped, oxaza. Here you are done with the prefix. Now we moving on to the stem. You refer table number 2 for the stem. So identify number of atoms in the ring. There are 6 atoms in the ring and the ring is unsaturated. So refer table number 2 for 6-membered ring which is unsaturated and contains nitrogen, oxygen. Name will be INE. And you will drop A, terminal A of prefix, and you can join the name. What will be the name? 1, 4 oxazine. So name will be 1, 4 oxazine. Now you have learned 3 rules of systematic nomenclature system, that is a Hantzsch-Widman system, right? According to Hantzsch-Widman system, the name of the heterocycle consists of 2 parts. One is prefix, second is stem. Stem indicates what? Heteroatom. Prefix indicate ring size, saturation, unsaturation. For prefix, you refer table number 1. For stem, you prefer table number 2. Rule number 2, what if there are multiple heteroatom? Multiple heteroatom, if they are identical, then you use this prefix di, tri, tetra before the prefix. So how you will write? You write di, tri, tetra, whatever it is, then you write prefix or prefixes, then you write prefixes actually here, because it will be di, tri, right? So you write di, tri, tetra, whatever is there, suitable thing. Then you write name of the prefixes, name of the prefix, then you write stem. Now moving on to the different heteroatom. Here there will be 2 prefix. Here there will be 2 prefix. So actually it is prefixes. In case of in case of rule number 2 it is prefix, and in case of rule number 3 it is prefixes. Okay, so 2 different prefix you will use and order will be according to table number 1. So how you will write the name according to rule number 3? If 2 or 3 different heteroatoms are present in the same ring, you write prefixes as per order table number 1 followed by the stem. So here you have learned 3 rules. Remaining 2 rules we will learn in the second part. Okay. So for this particular topic, I have referred R.R. Gupta, volume 1, page number 3 to 10. So whatever Hantzsch-Widman system rules I am going to cover, those rules are from this book. Thank you for listening patiently throughout the session.